Okay, ponder these two graphs. The one on the left, y equals 2 to the x. That was an exponential. Why is it an exponential? It's got an x in the exponent. Okay. And the other one, y equals log base 2 of x. That's the new one. That's the log graph. They're related. This one, if you want to graph it, you can use your calculator. Go ahead. You may remember how it looks like once you graph it. I'll do it by hand. Go ahead. That's fine. Use the calculator. Be faster. Okay, so you remember how this one looked? It got closer and closer there, but never touched, and then it went through this spot right here, and it went up. And the steeper, or the bigger the base, the steeper it went. So like, 3 to the x would have been steeper, and 4 to the x would be steeper, etc. Okay, now I want you to think about this one. It can be graphed. And I know you're going to think, well, how can I can't type it in like that. No, you can't type it in exactly the way you see it, but if you think about it, you can figure this out. Don't say it, please. Play around with some stuff and figure out how you could graph the other one. I'll hit pause while you do that. So since you can't just type in log base 2 of x, what could you type in that would be equal to that? Yes. Yes. Log of x over log of 2. You take these two pieces, put the bigger one, the one that's like higher on the top and the one that's a little lower on the bottom, just like we would normally do to put it into a calculator for base change. And that works. So if you haven't already done that, type that in. And now look at this one, and then look at this one. See how they're kind of related to each other? But in a way, they're completely different. Because if I were to take this one and write it out as a log base, something would be log base what? 2 of what? Y equals what? X. You see how that's kind of opposite of that? And you see how the graphs are kind of opposites of each other? If you compare this one to this one? They're not really opposites, but they're something else. And you have a guess in the name for these two graphs? They're related to each other in this way? Another name for opposites. No, it's none of those. Inverse, yes. They are inverses of each other. And if you learn more about inverses next year, when you learn more about inverses next year in pre-calc or PCAT, you'll learn that an inverse goes right over, if you're going to look at the graph, it'll go right over the line x equals y. So that if I take this guy and I move him over here, those two are inverses of each other if they flip exactly over that line. Now, I haven't drawn them perfectly, so they're not going to look perfect. Your calculator should be pretty darn perfect, though. And if you were to graph the line y equals x, you'll see that it goes a line right between the two that they could flip over. And that's how you can get the one from the other. All right, so the inverses, they're inverses of each other. The exponential and the log graphs are inverses. They're inverse functions from each other. But the main thing I need you to know is the parent of the logs. You kind of get what I'm going for here. I get to see these this summer. I'm excited about our trip. I'm going to go to Yosemite and a couple hours outside of San Francisco. So we're going to go visit there this summer. It's going to be awesome. So the parent of the logs that I actually want you to know is if I were to graph y equals log base, why don't I use 1? Base 1. Can't have base 1. It's not allowed. So I got to go with base 2 of x. If I was going to graph that, it kind of goes like this. Okay. But what are the important points that you'd put in on there? Well, back when we would do this one, y equals 2 to the x, that's kind of related. It's the inverse function. You'd pick things for x, like stick in x is 1, because that's easy to do, right? What's 2 to the 1? 2. And I'd stick in x is 0, because then what's 2 to the 0? 1. And then I'd stick in negative 1, and what's 2 to the negative 1? 1/2. It was easy to do it that way. But if you try to do that over here, take x, y, and you try to stick in 1 and 0 and negative 1, it's almost impossible because you're trying to figure out log base 2 of 1, and that means 2 to the what equals that number. It'd be a lot easier if you, since it's opposites, everything's like opposite of each other, the x and the y have been replaced. Any ideas what my 3 key points are going to be? Instead of sticking in 1 and 0 and negative 1 for x, I'm going to stick them in for y. Watch how easy it'll be to do. If I stick in 1 for y, can you do this in your head? 2 to the first is equal to x. So what's 2 to the first? 2. And if I stick in 0, I stick in the 0 here. And then it's saying 2 to the 0 power is equal to x. What's 2 to the 0? 1. And if I stick in negative 1 for y, if I stick in a negative 1 here instead, 2 to the negative 1, I can even do that. It's 1/2. So I got the same 3 points, except backwards. And when I graph it, 2 comma 1 over 2, up 1. 1 comma 0 over 1 up 0, and over 1/2 and down 1 will be right there. That kind of shows you where it should go. And then it gets closer and closer and never touches there. Okay, so there's your parent of the logs and the 3 key points. Notice you don't want to stick in things for x anymore. You want to stick them in for y. All right. And we've already done that, and that is as far as we need to go for today. The only other thing I could ask you is this. What if it was log base 5 of x? Where do you think it would change? Do you think it would still go through this point right here if I change it to base 5? You remember how the exponential one, when we did these, they all went through that same point. They just got steeper and steeper and steeper. You know what I'm talking about? They kept on going through this point right here. So this is always going to go through this point unless we shift it. And it goes up. And will it get higher like this, like the black line I drew, or will it be lower like this blue line when I make base bigger and bigger and bigger? More like the blue or more like the black? What's your gut feeling? Blue. And the way you can think of it as this one, it was getting tighter and tighter. It's like it's getting wound a little tighter and tighter each time. This one's going to get tighter and tighter also. Whereas the bigger the base gets, it'll just get tighter and tighter and tighter. Okay? All right. So if I asked you to graph the parent, you could sketch it by getting closer and closer to that and then hitting this one spot right there. And then if I wanted to have the parent be a bigger base, like log base 5 or something, it would just get tighter in like that. Okay, there's the main things that you need to know about application problems, like that one about the sand, where they give you an equation, and the main thing you need to know about the parent of the log functions. All right, that's all there is to it.